Assalamu alaikum. Today is our online lecture 23rd and today is the last lecture and our syllabus is complete for the final terms, and in the end of this lecture I will also tell you about the final syllabus for the exam. So let's start. Our last lecture is about lasers. Why I select this topic in the last is because it is the most advanced application of physics that is now applicable everywhere in the world. So today we will talk about what is laser, what are the characteristics of laser, its applications, advantages and disadvantages. So let's start. So word laser is abbreviation for L for light, A amplification, stimulated emission and radiation term coined by Jordan Koch, who is the founder of laser. Laser also get the Nobel Prize in early 1958, and it was invented and got the Nobel Prize in 1964, and it was based on the Einstein idea of particular wave duality. What is this idea? This idea was the same which we read in our previous two lectures, that light always travel in the form of waves. That was the this particle wave duality idea of Einstein. Third is originally called maser. Instead of laser, it's maser. Why? Because it was first invented in the with the communication of microwave. So that is why it was called maser. So the history of the patent is that first patent was related to laser was submitted or accepted in 1958. That was also see the maser, microwave amplification by stimulated emission of radiation. So it's all start with the microwave, but now today we get the light. The maser is similar to the laser but produced only microwaves. So you can also say that in our modern applications where we, because microwave is used for connectivity or for the transfer of data. So wherever we are using any type of connectivity or transferring data, that is also called maser. Now the characteristics of laser. What are the characteristics of laser? Coherence, high intensity, high directionality or high monochromity. So first start with coherence. The waves trains which are identical in phase and directions are called coherent waves. The definition can be, you can see from the, let me mark here on the screen. Okay, this is the coherent laser point, and this is the ordinary incoherent LED light. So laser is always coherent, it will always travel in a straight path, although it's in the form of wave, but in a straight path, not like LED light which spreads out everywhere. Second one is high intensity. Due to the coherent nature of laser, it has the ability to focus over a small area, and that can be 10 to the power minus 6. Because here in coherent laser lights are not scattered like in the LED light, so they are all going in the same path and direction. That's why it get high intensity. Third one is high directionality. The angular spread of a laser beam 1 millimeter per meter in one direction and non-spreading angular speed of 1 mm per meter. This high directionality is also because of the nature of coherence, because it's not spreading and going to the same direction. That's why it get high directionality. High monochromaticity. The light from a normal monochromaticity source spread over a range of wavelength of over 100 nanometer, but the spread is of the order of 1 nanometer for laser. In normal light, it's 100 nanometer, right? But in the laser, it's 1 nanometer. You can see the difference. That's why it is highly monochromaticity, because of the wavelength of the laser. Now we talk about the kinds of laser. Okay, here you can say kinds of laser. This is your home assignment, kinds of laser. Among the various kinds of laser, important laser are listed below. These lists you have to find out yourself. It's not a submission assignment. You don't need to submit this assignment, but you have to read about the types of the lasers. There can be different types of laser for cutting, for operations, all these kinds. You have to do this assignment by yourself at home, but no need to submit this assignment, because this lecture will not be included in your final exams. Now we talk about the applications of lasers. Lasers are mostly used in medical applications, military applications, industrial application, and lasers in the communication. One by one we will check all the applications, but from here let's start with lasers in communication. In optical fiber communication, laser bandwidth is very high compared to the radio and microwave communication. So bandwidth is high. This means high speed internet, high speed data transfer is possible while using optical fiber. As it has a large bandwidth, more amount of data can be sent. Same, because high bandwidth means broad spectrum. More channels can be simultaneously transmitted, so more telephone calls, more internet connections, more computer connection, more mobile communication, because of the broad spectrum. Lasers are also used in other communication devices, including high speed photocopier machines or printers. Everywhere now there are laser printers. Laser in the industry. Lasers can be used to blast holes in the diamonds and hard steels. So diamond and hard steel, which are the most, you can say, the powerful element. So if you want to crush them or make a hole or make any type of shape from them, we use lasers in the industry, and that are high powered lasers. Lasers can cut, drill, weld, remove metals from the surface and perform these operations even at surface inaccessible by mechanical methods, because lasers diameter is very small. That's why the parts of the machines or the metals where the instruments or our equipment cannot reach, we can make the laser to reach there and perform our task, cut, drill or weld. Laser's rangefinder is used to measure distance, to making maps by surveyors. If you have ever visited to a construction site of a very massive construction like roads, high-rise buildings,